So in our last video, you learned about some of the vocabulary terms that relate to regular polygons, and now we're going to learn how can we calculate the area of these shapes. And what I find super cool about this is that there's no longer a different formula for every shape. Now, any regular polygon, from 3 sides up to 135 sides and more, you can use the same formula. And it actually comes from a place that should make a lot of sense. So here's a regular polygon. In this case it's a hexagon, but it doesn't really matter what I drew. And because it's a regular polygon, we know there's some symmetry, right? So I could draw a line here, and those two sides are exactly the same. I could draw a line here, and the two lines are exactly the same, and the two halves are. I could draw this here, and the two halves are exactly the same. So I have now created 6 congruent triangles. You notice that there's one for each side of my shape. So if I can find the area of one of those triangles, if I can find this area, then I can just multiply that by 6 and find the area of my entire figure. So let's think. Area of a triangle, 1/2 base times height. And if we think about these triangles, the base of all of them is our side length, right? If that is our side length. And then the height, we learned about this term in our last video. This is our apothem. So if we can figure out what the side length and the apothem is, we can figure out the area of the triangle. And we notice that the number of triangles that you make is the same as the number of sides it has. So if I say that n is the number of sides, then I could say that the area of the polygon is equal to 1/2 the apothem times the side times n, where n is the number of sides. And that's our formula. That would work if this had 3 sides or if this had 300 sides. This same formula will work because we're always going to be able to split it into these congruent triangles. Now you might also see this formula written 1/2 the apothem times the perimeter, where P is our perimeter. And that's just because this right here, that is literally what perimeter is. It's the side length times the number of sides that you have. So that is perimeter. And you can see it written both ways. I kind of like this method just because it takes one calculation out, but this one might be easier to remember. So let's do some examples, and we're going to start off with an example where they give you all the values that you need. So in this example, I have a pentagon. So I know that n is 5. They also give me this side right here, which we know is our apothem. So I know that my A is 7. And then they give me a side length. So I know that S is 10.2. So to calculate my area, I'm going to write down my formula. And then I'm going to substitute in my values that they've given me in the problems. So my A is 7, the S is 10.2, and N is 5. And then I can use my calculator To figure that out, I'm going to do 1/2 times 7 times 10.2 times 5. And then we're going to get that our area is 178.5 square miles. So what I love about this formula is the formula itself is not incredibly complicated. The formula itself is only 3 numbers, they're just being multiplied. The thing that can get complicated sometimes is getting those values in the first place. So let's look at another example. In this case, I have a 6-sided shape, so that is a hexagon. So I know that n is 6. They tell me my apothem is 4 square root of 3. And then they give me this part of my side is 4. So I can go and figure out that the entire side is 8. So in this case, we had to do a tiny calculation to figure out that the entire side was 8 because they just gave us that portion there. So I can calculate my area. It's 1/2 A times S times N. So that's going to be 1/2 4 root 3 times 8 times 6. And because I'm doing this, I'm going to leave my answer exact. I'm going to do 4 times 8 times 6 divided by 2. And so our area is 96 square root of 3 square inches. You notice I just didn't put the root 3 into my calculator because I wanted to leave this answer in exact terms. So these are some of the nicer problems where they give you the apothem, and they either give you the side length or they give you something where you can pretty quickly find the side length. Sometimes, though, the problems are not as nice. If we look at these examples right here, in this case, I have an octagon. So I know that n is 8. And I see that my side length is 8. But they do not give me the apothem. So I'm going to have to be a mathematician here. And our first step is going to be calculate the apothem. And to do that, we can use some of these factors of right triangles that we've learned. Because I have a triangle right here. I know that this piece down here is 4 because it's half of the side. And I can calculate this angle. Because this angle is half of the central angle. So if I want to figure out my central angle, that's going to be 360 divided by 8, because it's 360 divided by the number of sides. So that's 45 degrees. And we want to remember our central angle would be this entire triangle. But I just want to have this part of it so that I can use the fact that it's a right triangle. So this angle right here is actually going to be 22.5 degrees. So now we have a triangle. We know that this angle is 22.5 degrees. We know that the bottom segment is 4, and I want to calculate A. This is a trigonometry problem. I can use tangent of 22.5 is going to be 4 divided by A. So I know that A is 4 over tangent of 22.5. And if I use my calculator, remember when we use our calculators, we always need to check that we are in the proper mode. And then I can do 4 divided by tangent of 22.5. And we get 9 point, I'm going to use 2 decimal places, so that is 9.66. So I can put that over here, 9.66. Now that we have our apothem, we can use our formula. So our next step will be to use 1/2 ASN. So our area is going to be 1/2. A was 9.66, S was 8, and N was 8. So I can use my calculator. 1/2 times 9.66 times 8 times 8. And we're going to get that our area is 309.12 square centimeters. So it looks like a lot, but this is just a trigonometry problem that you know how to do. And then we're just plugging it into our formula. So just like with our kites and trapezoids, where sometimes you had to do an additional calculation, you might have to do an additional calculation here. Now we've got one more example. In this case, I have a pentagon, so I know that n is 5. But they do not give me my apothem, they do not give me my side length, so I'm going to have to calculate both. So let's draw out our little triangle right here. We've got 5, know that A, this is A. I'm going to label this as X because it's not actually the side length, it's the side length divided by 2. Now what's our angle going to be? Well, our central angle is going to be 360 divided by 5, which is 72. So this angle is 72 divided by 2, which is 36 degrees. So I'm actually going to need to use sine and cosine because it's going to be a two-step calculation. So I could say sine of 36 is equal to x over 5. So x is 5 sine of 36. And if I do that on my calculator, we get 2.94. So this side is 2.94. And then here, you could use Pythagorean theorem, or you could use trig again. I'll use trig and say cosine of 36 is a over 5. So we have a equals 5 cosine of 36. And that is going to be 4.05. The last thing that I'm going to do is take that 2.94 and multiply it times 2 to get the side length. So I get that the side length is 5.88 and our apothem is 4.05. So now that we have all of our values, we can substitute those into our area formula. And I'm going to do area is 1/2, apothem, side length we calculated was 5.88 times 5. .88 times 5. And we're going to get that the area is 59.54 centimeters squared. I know this is a lot of work, but that's why it's important to be organized. You'll see how on every problem, I start by figuring out what information they give me, and I list out anything that I know, and then you always are going to draw this triangle. This triangle is going to bring you back to what you know about right triangles, and will help you solve it. Good luck.